Hi Grey Street, it is Tuesday, but something is very special about this week, Mr. White. What is it?
That is true. Well, it's not just week 3 of remote learning, but it is also a National Science Week. So what are we doing today about National Science Week, Mr. Nolan?
Well, we're going to create some lava lamps, Mr. White.
Ooh, lava lamp. See, how on earth do you get lava into a lamp? Because it's from a volcano, and it is incredibly hot.
That is correct. Unfortunately, we won't be using real lava. We'll be doing this in a much safer way.
Seems like a good idea for a primary school.
Absolutely.
Yes.
However, safety first, Mr. White.
Ah, yes.
Goggles on.
I do have safety goggles, but I better put them on.
Excellent.
Yes.
Now we're being safe. So let's have a look at our whiteboard here, Mr. White. So we've got our heading, which is lava lamp.
This seems very similar to a procedural text, but we better keep going. We've got an aim.
We do have an aim. Our aim for this is to make 3 different coloured lava lamps.
3.
Yes.
Okay.
Let's now look at our ingredients. We need water. We need vegetable oil.
Vegetable oil.
We need food colouring.
Food colouring. We've got 4 colours, Mr. Nolan.
Excellent. We have fizzy tablets.
Fizzy tablets.
And we also need 3 thin beakers.
Ta-da! Now, we don't have beakers today, but we do have some thin glass bottles, which we'll do for today, of course.
Righto. Let's get into it, Mr. White.
Okay, so first things first, we know a few things about these ingredients that we're going to be using, and a little bit about lava lamps, don't we, Mr. Nolan?
That is right, Mr. White.
Now, of course, one of these things, that a lava lamp works on 2 scientific principles, and you get to see them in action today, and those 2 principles are density and polarity. Now, density is the measurement of how compact a substance is, or how much it fits into a certain amount of space. But what's polarity, Mr. Nolan?
Well, polarity prevents oil and water from mixing together because they're opposite, just like magnets.
That's of course because all things are made up of atoms and they're all electrically charged.
Correct.
But let's get into the thick of it. Let's actually make this lava lamp.
I'm looking forward to this one, Mr. White.
So step 1, what we need to do is we need to pour a quarter of not the vegetable oil, even though I put my hand on it first, Mr. Nolan. We actually need to put a quarter of water in each of these 3 beakers.
Fantastic.
Now I'm going to let Mr. Nolan have a go of the first one.
Oh, here we go.
And then I'll have a go of the second one and I'll let him do the third one.
Now it was a quarter, Mr. White?
A quarter, roughly a quarter.
Righto, let's see if I can do this without spilling anything.
Now this is the biggest challenge, everyone, because Mr. Nolan is famous for spilling his drink bottle all over the classroom. I'm sure if you ask anyone in 4-5B, although he's done a fantastic job.
That looks like about a quarter to me, Mr.
Maybe the rumours are actually about me, Mr. Nolan.
Yes.
Alright, here we go. Second one, we're going for a quarter as well.
Here we go.
Oh, it spilled a little bit already.
That's okay.
Yeah, alright, just a little bit more. I might quickly do the third one as well.
Go for it.
Now, after we've done the water, what we're actually going to do is fill the rest of it up with oil, okay? So now that we've finished with our water, I'm going to seal it up and place it just underneath the table. So here's our vegetable oil. This is the second step. I'm going to let Mr. Nolan undo it. We need to put in double the amount of water that we've put in.
So we're putting in half of vegetable oil.
That's right, because 2 quarters make a half.
Absolutely. So let's start pouring this in now. Let's see if I can do this one as well without spilling.
Now, if you're doing this at home, a funnel will definitely make this easier. Unfortunately, I misplaced the funnel, so we're gonna have a go without doing it. Hopefully we won't get all over the classroom. Now I reckon, Mr. Nolan, if we can get just a little bit more in there.
A little bit more, sure.
Now we can see already in there that the water and the oil, immediately the water has sunk below the oil, and that's because that the water is heavier than the oil. And you can see that none of it has mixed in there. There's a lot of air bubbles, which is slowly filtering to the top. Now, we are roughly halfway through making our lava lamp.
Bit more to make it the same as the other one.
Now, of course, because we've got 3, we're going to make 3 different colours, because going back to our aim was to make 3 different coloured lava lamps, and we are definitely halfway there.
How's that looking, Mr. White?
We're looking pretty good. Our next step, Mr. Nolan, is definitely going to be one of the hardest steps that anyone during Science Week is going to have to make, especially Mr. Watt. Now, Mr. Watt did say that one of these lava lamps, he said one of them has to be purple.
Purple?
Purple. Now, but we've only got 4 colours and none of them are purple.
That is right, Mr. White.
Is there any way, maybe we might have to get Miss Brown in and help us with that one. I'm thinking from memory though, it might be blue and red.
I reckon we give it a go and
Let's give it a go. Let's give it a try.
see what happens.
But why don't we do that one last?
All
What's
right.
your favourite colour out of those four, Mr. Noel?
Well, out of those four, blue would have to be my favourite colour.
Well, I'm going to go, if you're going to go blue, I'm going to go green, okay?
Alrighty.
So the third step is putting our food colouring into the bottles. And it'll hopefully mix through and we'll see what happens.
Fantastic.
Alright, so Mr. Noel, if you want to go for one, I'm going to go for the N1.
No worries. Now, how much food colouring do we need to put in, Mr. White?
Now, Mr. Noel, we're going to try with 3 droplets first.
3 droplets.
And we're going to see how that sits.
Righto.
And then we might add some more there if it's not enough. Now be careful again, because if this can go everywhere. Some of you might like to wear gloves while doing this, but we will wash our hands thoroughly, because of course at the moment we have to wash our hands everywhere.
That is right.
Now this is going to take a little bit to sink in, so what we're going to do is we're going to let this keep going away, and we'll get back to you once it's sunk through for a bit.
So we'll see after these few short messages from our sponsors. Yours went.
Hey guys, as with all science experiments, mistakes can happen, and Mr. White has foolishly read the method around the wrong way. So we are going to quickly do a magic trick, and we're going to go backwards, and you might even see something really strange happen in a second. So Alakazam reverse!
Right, Mr. White?
We're back, we've done some consolidation on our evidence, and actually, Mr. Nolan, fun fact, from our research, we were correct the first time, because you could go either way. You can go oil or water.
Okay.
So now that we've gone incredibly fast backwards and forwards, we're actually going to we're going to speed this up, and we're going to put both of these back in, and our food dye, and we'll hopefully see you on the other side. Let's do this.
Let's do this.
Let's go. Now you'll actually see here, guys, that the food colouring has gone down, and that's because it's actually still heavier than the oil, so that's sunk to the bottom with the water. And you'll be able to see that nice and close up. Now, Mr. Nolan,
Yes.
we've got a bit of a problem.
We do.
Now, in a normal lava lamp, it's normally moving.
This
Isn't that right? So, in a normal lava lamp, you actually use a bit of heat to warm up the water, so there'd be an element warming it up. And that would make as the water heats up, it actually gets lighter and it rises to the top. That's because it slowly turns to a gas. Okay, because all things are made up of gas, liquids, and solids. Fun little fact there for you.
Absolutely.
But so we can't do that today, can we, Mr. Nolan?
No, we cannot. We need to be safe.
A little bit too dangerous for us to do. So
Yes.
we're actually going to use some fizzy tablets. So that's these things over here. And we'll do the purple one in a second. But we're going to do ours first, and we're going to pop them in.
Right.
And you'll actually see that we've each got a tablet. And we're going to drop these in. Now, how these actually work is they'll drop in and they'll react with the water, and they'll create carbon dioxide, which will be the bubbles, and that'll make the water float to the top. And when it gets to the top, well, the colour will go up and down like a lava lamp.
Absolutely.
So let's chuck them in and see
try
what
this
happens.
out.
Hopefully it works.
Actually, it doesn't.
Now we can see already straight away that the reaction's already working. You can see it's starting to bubble through and the
And
colours are
same
starting
with
to
the
mix.
blue. Here we go. And that is our lava lamp.
Sorry, that's pretty amazing, isn't it, Mr. Nolan?
Absolutely.
Alright, you guys, you can see already that it's already started to mix thoroughly through. Now, in fact, here you can see we've actually got quite a lot of water there, and at home you can experiment with the levels of water, and you might find that might come out a little bit better than ours. And already, the tablets have already started to stop fizzing, so it only goes for a short time, but it's still a pretty cool effect for at home. Now, we're actually going to repeat that, Mr. Nolan, and we're going to make a purple one in the middle.
Awesome.
Now, of course, we don't have purple in the colours.
We don't have purple. However, we can mix two colours together to hopefully make purple.
That's right. I remember Miss Brown saying something about that last term.
Yes.
So what colours do we need again?
We need blue.
Your favourite colour.
My
And
favourite colour.
green?
No, not green.
Not green,
Not
okay.
green.
Oh,
as much as you
okay.
like green, you know, with the
Yeah,
green
okay.
and all, not green. We need red.
Red. All right. Now we're gonna speed ourselves up a little bit here, mixing this one, and we'll see once it's mixed through.
Righto, let's do this.
Guys, you can see that our purple one is here. It is hopefully going to mix. The blue has just dropped with the red, and it's going to be a very dark purple.
Very dark purple, but that's okay.
That's okay.
Giving it a go.
It's a bit like a really dark grape colour.
Yes, absolutely.
But you might like to experiment with that at home. Of course, there's one more step we're going to add to this. Now, Mr. Nolan, it is Science Week, even though it might have disappeared behind me. That's okay.
It is Science Week.
It'll pop up eventually. But we're going to go one more step. We're going to make this even better.
Ooh,
Because
what are we going to do?
a lava lamp at home. Now, there's a heater element in there, but we've done this fizzy tablets. There's one more thing we can add to our lava lamp. Do you know what it is, Mr. Nolan?
Oh, I'm not sure. You better tell us, Mr. White.
Well, it's one of these lovely things called a light from a torch.
Ooh.
Okay, it's going to make it really stand out. So, in a moment, we're going to go over and pop it under a light and see if it makes it look fancy, and we'll catch you all next time. That'll be the end of our experiment from there. Too easy. So hopefully you enjoy the rest of Science Week, and we'll throw you back to Mr. Watt. See you guys.